Brief introduction. Hopefully most of you know who Power Sprays are. If you don't, we're the leading manufacturer of GRC equipment. We're celebrating our 60th anniversary, and we're based in Bristol, as James said earlier, which is about 100 miles west of here. My name's Richard. I'm the operations manager for Power Sprays and Fiber Technologies. Marcus, who's listed here, is our senior technician, and he's at the exhibition. So if you've got any questions, don't ask me, ask him. So a brief introduction to the presentation. GRC has historically been produced in a fairly labour-intensive manner. When mixing, the raw materials are usually manually loaded. And when casting, the material can be poured from jugs or directly from the mixing vessel. As we know, the sprayed process is inherently labour-intensive, and it requires skilled operators, who in some countries are very expensive and difficult to get hold of. But with new automation technologies emerging, there's now an opportunity to reduce the dependency on manual labour. Maybe not immediately, but looking to the future, it's getting better. It's getting better all the time. So this will allow for increases in efficiency, reduction of costs, and also reduced health and safety risks for workers. So I want to talk about three topics. I'll try and be quick in the presentation. Batching of materials, automated quality control, and automated spray stations. So start with batching of materials. So if you're doing it the old-fashioned way, without any dosing equipment, liquids have to be manually weighed or measured in a measuring cylinder or on scales. As we know, as you can imagine, this is pretty time-consuming, and more importantly, perhaps, is prone to human error. So the alternative, automated liquid dosing. With a system such as our WAPS 3000 dosing system, the quantity and the sequence of the liquids is pre-programmed. So, as you see in the video, you pre-program it with your up to 30 recipes, and with the push of a button, the liquids are dispensed either directly into the mixer or into a bucket, as you see in the video. This system also has a mode, automatic mode, where as soon as it's finished discharging the last mix, it will start weighing up the next. So if you're there in a mixer, you hit discharge, you do your mix. When you finish that, giving it to the spray guys, there's already a mix waiting for you. You hit discharge, the liquids are there. So although the actual weighing time is something like 2 minutes for a typical batch of GRC, the mix time is just as long. So it's actually like 10 seconds. You know, you hit discharge, 10 seconds later, you've got all your liquids. So that's liquids. Onto dry materials. Traditionally, again, pre-weighed bags of sand and cement are added directly to the mixer. Obviously, our GRC125 mixer is pretty commonly used by hopefully a lot of you. But it involves repetitive heavy lifting for the operator. And there's an EU directive. I know a lot of you aren't in the EU, including me. But the EU wants us to minimize manual handling. I won't read it out, but the point is, do as little manual handling as possible. That's what they're after. And this is a directive, not something they're going to be prosecuting you over, but these laws, they're only getting stricter and stricter, and they start in the EU and they spread worldwide. The other problem with manual batching of dry materials is, of course, it creates a lot of dust, which exposes both the operator and others in the vicinity. There's again, I don't have the references, but laws around respirable silica dust are just getting stricter and stricter. It has a workplace exposure limit of 0.1 milligrams per cubic meter, which means during an 8-hour period, a worker shouldn't inhale more than this much dust. Now, obviously, as you see in this video, it can be managed if they're wearing proper masks. But again, it's the same as the heavy lifting. The laws are only going to get stricter. So it's something to be aware of and to consider. An additional issue with manual batching of dry materials, not an issue, but a cost, is you have to get all the dry materials right next to the mixer before they can be loaded. So you might have a guy on a forklift spending half his time literally just moving sand and cement backwards and forwards around the factory. So the solution is an automated dry materials system where there's no need for manual handling. In such a system, all the dry materials are loaded via screw conveyors, and the outlets of the conveyors are sealed to the weigh hopper. So I'll briefly just show you on here what each piece is. So this here shows a screw conveyor for cement, and it's connected to either a big bag or potentially a hopper, but for cement, a big bag is usually better. This is a screw conveyor for sand. So they're both loaded into this weigh hopper, which is mounted on load cells, connected to the control system. Similar to the WAP's liquid system, the system weighs everything up, and then it gives you a little light to say the materials are ready. When you want to go, this is the what's the word? This is the valve, the discharge valve for dispensing the materials, and our system controls it so that it opens and closes rapidly, and it mimics the dry materials the way you would do it manually. You don't want 25, 50 kilos of stuff to just dump into the mixer, because it's going to trip the mixer. It's going to require too much torque. And then just below that, we have the diverter valve, so that you can choose whether it goes to mixer 1 or mixer 2. And I'll just show the mixer lid in such a system also needs to be modified. The benefit of this is the dry materials inlet is sealed to prevent dust egress, and it also incorporates a vent tube to just keep the dust all within the system, not allow it to escape. Oh, beg your pardon, I've gone too fast. Again, I'll just show you. So this is the inlet for the dry materials. Just behind the shaft here is the inlet for the liquids, and this is the vent tube. So this duct leads back up to the weigh hopper. So any dust that's generated during mixing or during the loading of the mixer, it's got nowhere to go but back into the weigh hopper, so nothing escapes into the environment. This here is just an inspection hatch. So as well as liquids and dry materials, we also offer choppers and chop fibre feeders. The fibre feeders are probably the most useful, actually, and can be fitted with vibrating chutes or vacuum systems to move the fibre anywhere in the factory within reason. And they can also be integrated into batching plants. We design these systems around glass fibre for obvious reasons, but they can also be used for chopped polypropylene and some other synthetic fibres. And we've got a lot of these now in concrete batching plants. In particular, polypropylene, I'm not sure how many people are aware of it, it's used in tunnel lining for fire resistance. So HS2, recently we've got a fibre dispenser installed in Avonmouth, actually. They're making tunnel lining. Oh, I should explain for people who aren't British, apologies. So HS2 is our very controversial high-speed rail line. It's going right through the middle of the country. It needs a lot of tunnels to avoid roads and farmland and what have you. And a huge amount of tunnel lining, and it's all got polypropylene in for this fire resistance. So one of our machines is there for that. So apart from the health and safety benefits and that sort of thing, there are also economic benefits of automated systems. It can save you money. With these types of systems, you'll have a higher output, fewer workers are needed, there's less waste, and there's more consistent mix quality, so fewer quality control issues. We recently installed a batching plant a couple of years ago, and the customer carried out an analysis before and after they had the plant, and they found there was an increase in output of over 40%. The workers they needed for manually weighing and feeding the mixer was reduced from 2 to 0, pretty significant reduction. And the raw material waste was reduced from 5% to 2%. In addition, the slurry quality, as I said, was more consistent, and they seem to think that saved them almost a whole person, having to just check everything all the time, and So based on this and our own sort of data that we have from other customers, I've very roughly calculated the payback period for a typical batching plant, although there's no such thing as a typical batching plant. So compact batching plants are less expensive and therefore have a quicker payback period. And by compact batching plant, I mean a simple system with all the dry materials being fed from either a big bag dispenser or just a big hopper, and then feeding to our sort of standard mixers. A larger batching plant might be connected to silos, and it would be perhaps feeding bigger mixers or platform-mounted mixers. So the larger batching plants, more expensive, considerably more in some cases, but they can still be a good option if you have the output to justify it. So on this graph, I'll just explain. The blue column is a batching plant on all of these, and the orange column is for the larger batching plant. The payback period shown here, the number on the y-axis, is tons of GRC. So in West Europe, North America, where labour is expensive, it's really worthwhile getting a batching plant. Depending, again, I'm using very, very rough labour costs and looking at raw material costs as they are in the UK. But the payback period can be as low as sort of between 500 and 1,000 tonnes of GRC. As you go further east and the labour cost reduces, perhaps it's a little bit harder to justify, but even there, the period can be as low as 1 or 2 years. So it's well worth considering. Okay, on to automated quality control. So the European standard specifies that you've got to check the output of the slurry and the fibre when you're spraying GRC, and this is typically done at the beginning of a shift or beginning of the day, using the bag and bucket tests that we all know and love. Don't know. So it's a bit of a nuisance, as we know. So to help a little bit, all our spray stations now are fitted with a bucket test function. This is very simple. All it does is illuminate an LED for 30 seconds. So it's not life-changing, but you still have to perform the test manually. But it's a little bit helpful instead of having a guy with a watch going start, stop. There's less chance of error. More usefully is the bag test function. Again, all our machines have this now. And this opens a valve leading to the air motor for exactly 15 seconds. And this is really useful. It gives consistent, accurate results for the bag test. There's no chance of human error. I'll just show the whole video now. You'll see Marcus is already holding the trigger as he presses the button. The button opens the valve for exactly 15 seconds, and it closes the valve without having to do anything. I had to cut the video off there just before Marcus lifts his arm up and shows off his belly. So those are great, they're pretty useful, but they still have to be done manually. They take time. And most importantly, they can only be done when production is not ongoing. As I said, normally you do it at the beginning of the shift. But that doesn't really give you much opportunity to check during the day. Outputs can change during the day. Humidity, temperature. A big one we find is you start at the beginning of the day before a lot of people are in and working. Everything seems fine. During the day, somebody starts using an air tool or several air tools, and if you haven't got plenty of capacity in your air system, that's going to affect the air delivery to your spray station, and the output might change. So we've developed a system that gives you a live reading of the output on demand. We've not quite perfected it, but it's almost ready. We've got a demo unit here, which Marcus can demonstrate at lunchtime. So I'll show this video again. As the video starts, the fibre is already being chopped. So it's as if it was a real production. You can just go and do this test. You don't even have to tell the spray guy you're doing it. He's chopping away, you start the machine, and it'll record how much fibre there is. So you hit start there. You see the live weight of the roving shown here, and it's running the test for 15 seconds. There we go, 15 seconds is up, and that was the quantity of fibre used, and it gives you the output in grams per minute. You can go on here as well and see all your most recent results. The layout shown here is an older one. We've since changed it, but you get the idea. You can see the new version on our demo unit. So finally, and very briefly, as the session is looking to the future, I'll talk about automated spray systems and how they could work. So the robots are coming, but don't be afraid because they look like this. So as you've seen yesterday, we've had a few presentations already on this. There have been huge advances in robotic systems. And interest is everyone's always wanted to use robots. It's sort of the holy grail of the GRC industry, I think, to get rid of all the people, just use robots. That'd be nice. And as I said, there's been some development in universities you've seen yesterday, and I think a presentation later today. But there are some obstacles. Some manual interaction is still required. I don't think anybody can say that a robot can use a spring compaction roller. In addition, no cement batch to batch is perfect and is exactly the same. Same with sand. You know, there's always something that needs a little bit of thinking, let's call it. In addition, if there's a lot of repetition, the programming time could be worthwhile. But how many projects are there where there's the odd panel, there's a one-off, or there's only a couple of them, and justifying the programming time for that, at the moment, I don't think it's worth it. But they continue to improve, and with recent accelerated growth in AI, ChatGPT, that sort of thing, I think there will be some rapid improvements in the coming years. If you can imagine, if you didn't need to do the programming, if a robot could look at a mold and say, "Oh, this is how I'll do it," it's a different equation, you know. And these sort of technologies have the potential to transform our industry. So, in summary, the construction industry historically has been pretty slow to adapt to modern technologies, but the current rate of advancement is changing all industries on an unprecedented scale. And we, as a GRC industry, have to start taking advantage of these technologies in order to remain competitive. Thank you very much.